Hello everybody. What we'd like to do today is make a video for all the parents of students at Wega who want to know how matter and light, space and time really fit together. Now Einstein fits together matter and light, matter and energy, but he shows that they're both just energy. So energy equals mc squared. This is the total amount of energy that I get out of mass, c squared, matter. It's the same thing, but I need huge amounts of energy to make matter. It's just more energy than light. Now what we're going to show you today is that space is also energy. And we need to put that together with time. So Einstein's got this sorted out, but he hasn't got space and time sorted out. Now we've done that and we've put them together in a pattern, but I'm going to tell you how we did it. This was a mix of Chinese philosophy and Western science. Western science, as it stands, cannot explain what we observe in nature. And that's simply because if I take Western physics like this, it cannot tell me how the elements in this rock change into the elements that do this inside DNA. It cannot go from something which is all disordered and messy into something which is beautifully ordered and precise. It cannot tell me how the solar system changes from just dust and elements at the beginning into a beautiful clock. This clock counts the motions of the solar system which made itself. And if I look in my physics book, I only find gravity. Gravity is just the battery that holds it together and makes it move. But the gears inside the clock, what makes them? So we used a very different approach to the Western approach of always trying to decide it's just one answer, physics. It's not, and it can't be. We looked at reality and saw that it's two answers at the same time, just the same as energy and matter are two parts of the same thing, electricity and magnets are two parts of the same thing, left and right are two parts of the same thing, male and female are two parts of the same thing. And if we go back in mathematics, we find that mathematics is always two parts of the same thing, rational numbers, irrational numbers, the square root of 2. Numbers I can count, counting numbers. Numbers I can't count, prime numbers, or numbers like pi, beautiful ratios, the infinite and the finite. But Chinese philosophy always looks at things as a double way of looking at things, two answers all the same time. So we thought, well, why not stop just saying there's one answer and see if we say there are two, if we can describe reality much more sensibly. And you can. So this is what we've come up with. Mathematics and physics are both the same thing. And you need this mathematics in here to describe the complex worlds of chemistry and biology. But this is pure mathematics. But that's now okay. I can use pure mathematics and the physics, the mathematics in here, and just put them together and I can answer the questions that Western science cannot answer at the minute. So mathematics and numbers, elements and numbers are the same thing. And if you look in science book, you will see that atomic theory, the theory of atoms, is always just described by number theory, mathematical theories, sometimes written hundreds of years ago. So let's now show you how things really work, just using numbers and science as the same thing. If I take my real numbers of mathematics, the elements, these are positive numbers. Positive real numbers. Elements, matter. These are the most energy. It's just huge amounts of energy squashed into a very tiny space. And it's that energy that comes out of atomic bombs when we see it. So it's just the most energy, but it is just energy. That's very hard to look at a rock and think that it's just energy. Well, that energy, if it comes in positive and negative parts, both attracts itself and repels at the same time until it gets bigger and bigger and bigger, until it gets to something about the size of a flea egg. And we call this the Planck mass, a mass when something starts to behave relative to gravity. So I've got two worlds all at the same time. I've got down at the atomic scale a mathematical world, little bits of mass, which are just relationships, little bits of volume, which are just relationships between the parts that repel. So let's have a look at my real numbers, which are minus. You'll see that everything just fits light. So here is E equals mc squared, matter, and radiation energy. This is just lots less energy. But now I can clump all this together, my real numbers, and say that's all plus. Whoops. And space, I need some numbers for space. When I look at magnets like that, I've got the real numbers here, and I'm using the real numbers of light to see it, the real numbers of matter to hold it, but there must be some numbers to describe this space. And there are. If I look in mathematics, we find numbers called imaginary numbers, and we represent them on a diagram like this. Now let's just show you how easy it is to see all the different parts of relativity when I put them into a diagram like this. Magnetic fields, electrical fields, are very, very strong. So space energy. So this is going to be minus energy. It's always just opposites, vectors. This is the strong electric magnetic fields. So let's represent those as positive imaginary numbers. Plus I plus 2I plus 3I. And the numbers that make gravitational space, the weakest kind of energy, if I look down at these little numbers, they're very mathematical, represented by relationships between 1 and 2 pi, and tiny, tiny, tiny amounts of energy. So this is my minus I minus 2I minus 3I. So here's the most energy, and then light, and then the energy levels of electrical and magnetic fields, and the energy levels that make gravitational fields. And now we're going to use relativity, relationships between all the parts, to show you the parts of physics that we get. Things that make themselves if you just put these numbers in each other's presence, you just put them together. If I take the elements, matter, and put it into space, I get gravitational fields. Now they pull in the same direction inwards. They don't have poles. Now, we used to say, well, a star's made by gravity, but that's not true. Remember, we always need a double answer, one mathematics and one physics, physical. The star's a physical thing, but the elements in the middle of the star, which are pushing, making the energy to push that star out, are not physical things. So I've got geometries and numbers making each other. I've got a push coming out from the elements made of two opposite forces, the strong and weak nuclear forces which make the elements, and electromagnetic forces which try and repel, and it stops the nucleus from being too big. So what I've got here is that is a push, and that is a pull, And I've got the gravity numbers here, the pull of the star, so that's the pull, but the energy coming out from the elements, that's a push. So I see here that everything's always 2. I've got the elements being made of a pull and a push. This force pulling, this force pushing. It stops the elements getting too big. And then the star pulling in and the energy being released from the elements pushing out, and they balance each other. It always starts to balance. Now this is the start of evolution. I'm making things, and I always get 2 things at the same time. Now we must always have things in pairs. So gravity must have an equal partner that stops the Earth from going into the Sun. And it does. And it must be made of 2, it must be geometrical, and it's made of the 2 laws of conservation of linear momentum and angular momentum. The properties of space which doesn't have units that I can count because they're imaginary. The square root of -1. I have a relationship between matter trying to continue in space and go around the conservation of angular momentum as it's pulled in towards the Sun, and it balances just in one place. Now these 2 geometries we call Euclidean geometry and non-Euclidean geometry. So that is uniform acceleration. Uniform acceleration is the opposite partner of gravity. Everything must have an opposite. It's the qualities of space that give it uniform acceleration. Now, if I go back to my little diagram, well, here I've got the evolution of stars and elements. What have I got if I put matter and the virtual particles, the imaginary particles that make electrical and magnetic fields? Well, I can draw the Earth. There's a gravitational field, but now there's a magnetic field. These are very strong fields outside the Earth. Here would be a gravitational field. Here are electric and magnetic fields, the relationship between these numbers and these numbers. And the relationship between the magnetic virtual numbers and the photons, the numbers here of light, the particles of light. Photons, and I get here electrical, magnetic waves. I always get 2, they're polarized. I get electric, magnetic waves. That's light. So the speed of light is a relationship which goes in here. So what have I got here? A relationship between light and the numbers that make space. Well, what Einstein showed us is something called gravitational lensing. That space will bend and light sticks to space, will bend around a heavy object. Imagine a black hole. That matter, space changes matter into spheres, but if I have enough matter, it changes space into spheres. These are the Schwarzschild radius around the black hole. Light just goes round and round and doesn't come out, so we say it's black. But any light going past that will bend. And we've seen that. Einstein predicted it. Gravitational lensing, light and space in a relationship. Well, that's very, very simple. I can see all the different parts of physics, but this is simple. The stars and the elements, these are the first stars. Very, very simple. There's no chemistry, no life, no water. Well, now we need to bring in time, because I put together space, gravity, and then the conservation of angular momentum and linear momentum, weak space, positive energy, negative energy. So now I want to continue with my evolution and become more complex. When this star explodes, when I break that balance between the push and the pull, there's no more push when you make iron. So if there's no push and lots of pull, the star collapses and throws out the elements. But now I've got lots of elements, it's more complex. Gravity will again pull them back together, but this time the electromagnetic repulsion inside the Earth holds it up, it's still just made of energy, but now I start to get chemistry and biology. And you'll see that you'll get mathematical structures that we call viruses and life. Once again, a double answer. And that just goes on becoming more and more complex. Under the complex, we have the simplicities of the physics here, and then I get chemistry and life, taking me on a long journey up a complexity gradient. You can also show it just like this, that things act against each other. And there's always two answers. One, when it's very small, the elements, we say it's much more mathematical than physical. Atoms don't really have physical presence, but they do have lots of mathematical presence. There's a tiny bit of volume inside a proton, but it's so small, it's more mathematical than physical. But objects, we can say, are more physical than mathematical. So here is physical and not so mathematical, but here it's mathematical, not so much physical. So I'm going to say that physics equals mathematics. It's two parts of the same thing. And just like my equation, I can have more physics, less mathematics, or more mathematics, less physics. So that's really how we do it here. And anybody can understand this. We've got these beautiful charts, which if you would like copies of these charts, we can pass them out to you, and that shows how everything becomes more and more complex. So I hope we've tidied things up for you a bit today. This is how space, time, and matter and light fit together. I get time coming out of the relationship between these numbers, and that must also come time which is plus, time which is minus. So here, as we make things, the time is positive, it's plus. I'm making stars and elements. When we go back this way, it's breaking things. Time, which is minus. When you die, all your elements get taken down and put into the soil. A little seed falls in the soil and it starts to make things, and I get time, which is plus. So we can show it all like this. The quantities, this is the physics of everything. The qualities of everything, the qualities of space, doesn't have any numbers. And the two parts of time, which must be equal to satisfy something we call Noether's principle. Now what we've also done is to show that there's a little mathematical ratios that sit between here, and that is 1.65, and time plus is also 1.65, and minus 1.65. There's time minus. So that's how it all fits together. Very simple. We haven't just pulled all this out of the hat. This has been peer reviewed and checked again and again and again by professors in the universities here in Taiwan, until they said, well, we can't find anything that's wrong with this. So now you can teach it to your students. Thanks for watching. Bye bye now.